In this problem, we're going to let E and O represent even numbers and odd numbers, and then we're going to complete a multiplication table. So if I multiply two even numbers, then the result itself is going to be an even number. So I look at the intersection of where we have the two even numbers, or two E's, and an even times an even gives me an even. And in fact, if I multiply an even number by anything, then I get an even number. So I'm also going to get an E when we look at E multiplied by O, or an even multiplied by an odd. And the same thing if we have an odd multiplied by an even. We also get an even. And then if we multiply an odd number times an odd number, then that result will be an odd number. So that's my table. Now we want to determine if this forms a commutative group under the operation of multiplication. So the first thing I'm going to check for is, do we have closure? Well, our elements are E and O. That's what we had in our top row and our first column here. And then the multiplication results are all E's and O's. So we do have closure. Next thing we look for is this associative? And we're going to say yes for associative. So since this is multiplication with numbers, we know that multiplication is associative. So we can confidently say that this is associative. Next, we look for an identity element. So that would be an element that if you multiply it by anything else gives you that same result. So since my top column, let me do this, is E and O, I'm looking for another E and O that match that, and that would be in the second row here. Did I say the top column, the top row? And then we compare that with that row. So we get odd would be our identity element, actually. Because O always gives you the same result. And we can see that that works with the columns as well as with the rows. So now I want to find inverses. So we want to see E times what would give me the identity element O. And E does not have an inverse. So it would not be a commutative group because it's not a group. So that's the end of that.